Okay, I have started recording, and now I'm going to share my screen. And let me find the file I need to. Okay, these are the notes. And what I wanted to do first, I had originally planned just to talk about quadratic and exponential models, but a student or two told me they were still having a few issues with linear. So I decided to do some homework on the same app you guys use. See up here at the top, there's a guy named Robert Engineer. That's a dummy student I created so that I could go in just like you and do the homework. So I thought I would just go ahead and do it and go through some of this, start the assessment. And turns out what I want to do is I want to be able to write on this, and that particular app I can't write. So I'm going to grab part of the screen and copy it to this file here. So let's see. Okay, this is a linear problem. A city currently has 125 street lights. They plan to install 3 additional street lights at the end of each week for the next 52 weeks. How many street lights will this city have at the end of 35 weeks? So don't let the 52 fool you. That's not going to be part of the problem. You want to know how many you have at the end of 35 weeks. So this is going to be a linear problem. If you let y be the number of the street lights, you know you start with 125 and you add 2 each, or 3 each week. So every week you're going to add 3, so the slope is going to be 3. So does everybody see that this is a linear equation that tells you how many you have at the end of each week? If x is 0, means you haven't started and you have the original 125. So the end of 35 weeks is going to be 3 times 35 plus 125. Somebody have your calculator out there and tell me. Well, I can maybe do it. Check my work, okay. Do you get 230?
Yes, sir.
Okay, 230. So that should be the answer. So if I go back and put 230 here. And it said I got it right, but it only gave me 70%. Maybe that's because I'm late. Okay. So next question. We got a table here of x and f of x. And you want to just fill in that blank place there. What do you first notice about this? You go from 4 to 6, and you go down how much?
$10.
You go down 10. And then so you go from 6 to 8, and you go down 10 also. So the slope of this is -5 per every 1, or -10 for every 2 that you go down. So you're going to go down another -10. So it's going to be -47. Should be correct. Okay, the next question is find the equation of the linear function that passes through the points -3 and 7 and 6 and 1. And there's a pretty neat app here that allows you to draw in an equation or draw in a graph. So we want to go to -3 and 7, and that's there, if I'm seeing right, and then go to 6 and 1.
That was -4 and 7.
Okay. -3 and 7. If I look at this on my small laptop, I don't see quite as well. -3 and 7. Now I'm looking at it on a big screen. So -3 and 7 and 6 and 1. Okay. And be sure, check your work and make sure you put the dots in the right place. And it asks you state the slope between the points as a reduced fraction. Tell you what, I want to grab this. Okay. I didn't mean to. I'm messing around here. I wanted to clear all that off. Come on. This is not cooperating. Let me get a new clean sheet. I got to go back in and grab it, Copy it again. Okay. There are several ways to look at this. Actually, if you look at the graph, you can see that from this point to this point, as you go over 1, 2, 3, 4, 5, 6, 7, go over 9, it goes down by how much? It goes down by 6. Okay. So the slope would be minus 6 over 9. If I drew this right. It goes down 6 as it goes over 9. So the slope is minus 6/9 or minus 2/3. So that's going to be the slope. So we're going to put to minus 2/3 here. What is the y-intercept? The y-intercept is what? It's 5. So it would be x equals 0 and y equals 5. Now I notice that sometimes, you know, the y-intercept is really supposed to be 2 points. The x value being 0 and the y value being the y value on the y-axis. But I noticed on one of the other questions, you should have just put in 5. We'll see what we should put in a second. The linear function is not going to be, well, it would be f of x equal minus 2/3 x plus the y-intercept, which is 5. Some people would put in y equal minus 2/3 x plus 5, and it would tell you it was wrong. So let's go back. It's minus 2/3. Oh, come on. Minus, come on. Now it won't let me type anything in. Okay, I'm going to just do it this way, minus 2. I think this will work. Minus 2/3. And the y-intercept, I think it wants it to be 0 and 5. We'll find out in a minute. The linear equation should be f of x equals minus 2/3 x plus 5. Okay, so notice you get another chance. Okay, so they're all correct. By the way, there's another problem in here in which if you put 0 and 5, it would count it wrong, and you'd have to go back in and put 5. So this app is not always consistent. Somebody came in on the iPhone. Who is that?
Hey, Dr. Brown, this is Khadija.
This is who?
Khadija Kitchens.
Kitchens. Okay. Very good. How are you doing?
I'm fine. How you doing?
Okay. You can look at the video for the first part to see what we've been doing. I'm actually working some of the homework. Okay, let's go to the next question. Now we just have a linear function here, y equals minus 4x plus 5. I think everybody should realize that the slope is minus 4 and the y-intercept is 5. So the slope is minus 4, y-intercept. Now notice this, I'm going to put 5 there. If I put 0 and 5, it would be wrong. And now we want to graph the equation. Well, the easiest way to graph it is to see that the y-intercept is 5. So I'll go right up here. And I want to put the next point so that will have a slope of 4. Does everybody see that?
What?
If I go over 1, it should go down by 4. That's what it's done here. There it is. Anybody got any questions?
Not so far. It's good.
Okay, says we got those correct. Okay. Let me copy this. Maybe somebody should mute their. Okay. Now I'll be able to write on this. Okay, we've got we want to create a cost function where X is the number of miles driven when you rent a car for a day is going to be $45 no matter how many miles you go, plus 25 cents a mile or a quarter of a dollar per mile. What is the slope of the linear function and its units? Well, the slope is going to be 0.25. And it's going to be dollars per mile. We'll put that in a second. What is the y-intercept and its units? The y-intercept, well, the equation is going to be C of X is going to be 0.25 X plus $45. So the y-intercept is going to be 45, and we'll pick dollars. I think it's what we'll pick. And what is a linear function? 0.25x plus 45. If you have any questions or see a mistake, let me know. So this should be 0.25 dollars per mile. The y-intercept is $45. And the linear function is c of x equals 0.25 x plus 45. And submit the question, and looks like we got them all right. Let's go. Well, that's all the questions. We're finished on this one, okay? So, anybody have any questions about linear? One of the things, everybody should get their notes for all of these videos and pull out the ones of the ones that have the equations. Okay, I think we've gone over the important ones. But for instance, knowing that y equal mx plus b, and the slope is y2 minus y1 over x2 minus x1, and that the equation for a line is y minus y1 equal m times x minus x1 is the equation for a line if you have the point and the slope. So have all these ready on your test, okay? You don't have to memorize all these, but probably you are beginning to memorize some of them yourself. Okay. Now for the things I had planned to talk about before someone mentioned they wanted to know something about linear. Here are quadratic. Here's some of the homework on the quadratic. And I believe I can write on this one. Find all the zeros of this function. How would you do this? Some of you already done your homework. How did you do this one or one like it? Miranda, how did you do it?
Honestly, you set it equal to 0, but I don't remember how I did that.
Okay. Well, a fallback position always is the quadratic formula.
Okay.
Just plug into that, and that will always give you the answer. And it'll give you two answers if b squared minus 4ac is not equal to 0. It'll give you two. It'll give you two of equal answers if it's 0, and it won't give you. It'll give you imaginary answers if b squared minus 4ac is negative. But by far the easiest way to solve this, if you remember how to factor, is to factor the thing. And let me see, I think the factors would be x minus 12. Let's see, x minus 12 and x plus 8. I had to think about that for a second to realize 8 times 12 is 96. Okay, does everybody remember how to FOIL to check your work? To check that you multiply this out, you go first outside is plus 8x. The inside is minus 12x. So to add those together, you get minus 4x. And then minus 12 times 8 is minus 96. So you set this equal to 0. That means that x minus 12 is equal to 0. And x equals 12, or x plus 8 equals 0. So x equals minus 8. Now, I'd already put this in, and there are the answers, minus 8 and 12. Okay. However, if you get stuck and you can't come up with the two factors, then use this, and it takes a little longer. And you need to identify the A, which is 1, the B is minus 4, and the C is minus 96. So this is going to give you some big numbers. Minus B is going to be minus 4, plus or minus the square root. B squared, which is minus 4 squared, minus 4 times A times C, which is minus 96, all over 2A, which is 2. So x equals 4 plus or minus the square root. This is minus 4 squared is 16. And it looks like we got 4 times 96, which is I'm doing this in my head. What is 16 plus 384?
$400.
Okay, 400, okay. Okay. Now that the square root of 400 is 20, all divided by 2. So we have 4 plus 20 divided by 2, which is 12. And we got 4 minus 20, which is minus 16 over 2. It's equal to minus 8. So it's the same numbers we thought it was, okay? Now, obviously, doing the quadratic formula may have taken a little bit longer unless it took you forever to come up with the factors. Okay. The vertex of this quadratic function. The vertex is always going to be either the low point or the high point. Okay. And the h value, the x value of is going to be minus b over 2a. You need to have that formula close to you. Well, a is 1, b is minus 14, and c is 24. We don't need c to find the vertex, by the way, or at least to find the h value. So the h value is minus b, which is minus 14, divided by 2a, which is 2. So it's going to be 7. So the x value of the vertex is 7. By the way, since a is more than 0, it's going to open up. So it's going to look like this. So that this point is going to be 7. And to find the y value, we need to plug it in. So k is going to be f of 7, which is going to be 7 squared minus 14 times 7 plus 24. Oh, is anybody doing this?
I'm kind of lost on this one, to be honest.
Okay, let's get you unlost. Do you understand the h?
Yes, sir.
That just basically gives you the x value of the vertex, either the lowest or the highest point. To find the y value, you have to plug it in to the function. Okay, so we're going to put in x equal 7. And that'll give you the y value. So you plug in x equals 7, you get 7 squared minus 14 times 7 plus 24.
Okay, I got you.
Okay. Now somebody should have had their hot calculator out. Has anybody done this one? I think, folks, I've got a cheat sheet on the other side. It's minus 25. So if you put that in your calculator, you'll get minus 25. So the answer is 7 and minus 25. Okay. This is a little bit of theory about a quadratic function. We've got a graph here of a quadratic function. What can you say about the value of a and the discriminant? Okay. Well, what is a going to be? Is it going to be negative or positive? It's opening down, right? So a is less than 0. Now, what determines the value of the discriminant? Whether it's 0, more than 0, or less than 0? Destiny, do you remember?
You said what, sir?
Huh?
Can you repeat that?
How do you figure out what the value of the discriminant would be? by looking at the graph, if you saw the graph.
I think whether it's going,
Okay, this is x-axis and y-axis. First of all, does it have two real roots? Can you see the real roots? Where does it go through the x-axis? It's got two distinct points. If that is the case, then it is greater than 0, the discriminant. The discriminant is the square root of b squared minus 4ac. So if this is more than 0, the real roots would be minus b plus or minus the square root of b squared minus 4ac all over 2a. Obviously, to get minus b plus or minus something, this has to be positive. So if it's positive, it'll have two real roots. If it looked like this, it would also have two real roots. And that means the discriminant's got to be positive. Now, you can have a different situation. If it looks like that, it doesn't cross the x-axis. It has no real zeros. It never touches, okay? That means you have complex roots. And b squared minus 4ac is less than 0. So you're trying to take the square root of a negative number, and remember that's going to be, suppose it was minus 16, that would be 4i. So that you have your imaginary complex roots. On the same token, if it looks like this, it's not going through the x-axis. So the discriminant is going to be negative 2. Now the other case is, well, let me erase some things. If it, let's just say it did this. Boy, I can't draw very well. Suppose it just comes down and just touches the x-axis at one point. And suppose this were minus 5. So it has two equal roots of minus 5 and minus 5. It's called a repeated root. So the only solution is minus 5. And that's if b squared minus 4ac equals 0. So if this is 0, then the roots are minus b over 2a. Okay? So who can tell me the answer to this? The value of a is what? It opens up or down? It opens down, right? So a is less than 0. Now, is it going through the x-axis? It's not touching the x-axis at all. That means the discriminant is less than 0. Okay. Okay, now exponential functions. Now this one is about when way back a good while ago, we had an AIDS epidemic and the number of people dying was increasing rapidly. And it says the growth multiplier was 2.2. In 1983, there were 1,800 people in the US that died of AIDS. If the trend had continued unchecked, how many people would have died by 2005, in the year 2005? So how many years between 83 and 2005? That's 22 years. So the number would then be equal to 1,800, which is the value started off with, times the growth multiplier to the 22nd power. Okay. Which is a huge number. Can you do that in your calculator? I think I put it in my calculator, or did I? Okay. Everybody put that in their calculator to see that you can reproduce this, okay? Miranda, you have your calculator? Okay. Did you get this?
I didn't get that. I must have misundered it. Let me try again. It was
Let's make sure. 800. Oh.
it's just the 2.2.
Hey, everybody look at what I just wrote down.
Okay.
What did I do wrong? What number did I put in 2 for the growth multiplier instead of 2.2? So you got to catch me on that. (2.2 to the 22nd power)
Okay.
times 1,800. That should give you.
Yeah, that's what I got.
Okay. So it just goes to show, check your work. Okay. Notice that I just wrote down, I think I said 2.2, but I put 2 down. Now, the growth rate of this population here is 8%. That means that R is 0.08. So what is the growth multiplier? Growth multiplier is 1 plus R equal 1.08. So the difference in the times of 2000 and 2020 is 20 years. So the population will be what you started out with, which was 200,000, times 1.08 to the 20th power. Now, put that in your calculator. In fact, heck, let me do that. I'll bring my calculator up. So let's try this. 200,000 times 1.08 to the 20th power equals 932,191. That should be what I've got here, 932,191. So that's the number you would have 20 years later. Okay, things can go down as well as go up. So you heard of inflation can cause the value of money to decrease. We're talking about a situation here in which the inflation rate is 3% each year. So the rate would be 0.03 minus 0.03. So if it's going, if it's decreasing, then the rate will be a decimal with a negative sign. So the growth multiplier would be 0.97. Just as it says here, from 1 year to the next, if it was things were worth $1, 1 year $1 would be worth 0.97 the next year. So how much will $100 buy you in 20 years? The value in 20 years would be $100 times 0.97 to the 20th power. So let's see how much that dollar would be worth. Okay, to the 20th power. $54.38. If you round it off to the nearest cent, $54.38. So there we are. Okay, the next one. One of the things that goes down is $1. Another thing that goes down is the value of a vehicle that you may purchase new, and it may depreciate at a certain rate. In this case, we're talking about a $20,700 vehicle when it's new, going down at 9%. So R is minus 0.09. So 1 plus R is 0.91. So the value of this vehicle in 15 years is going to be $20,700 times 0.91 to the 15th power. So let's put that in the calculator. $20,700 times 0.91 to the 15th power. So that vehicle is going to be worth, to the nearest dollar, $5,030. Okay, 5,030, there we go. Now, this problem is just to match up the different kinds of functions. We really haven't talked about logistic functions. I'll say something about that in a moment. The first one, obviously, is a straight line, and it's linear. The third one is going up, not in a straight line, but what looks like an exponential function. So that would be B. But it turns out there's another kind of function that I'll just draw here. It may start out like it's increasing pretty rapidly, but it may flatten out. And that's called a logistic curve, okay? We're not going to really have equations for that, okay? Sometimes you'll see this kind of function in, say, a business situation. Let's think about age versus salary. Suppose you went in and started out at a salary of $20,000 a year when you had zero experience. And your salary might go up every year. However, at some point, it may flatten out unless you're getting raises for inflation or something to, say, maybe $80,000. Okay, that's a logistics curve. Now, this is the same kind of problem, except you're given the equation. And this is the value of a vehicle versus time, where T is years. How would you interpret this? You would say the value of the car is decreasing. Why is it decreasing? Because this factor is less than 1. It would be increasing if it was more than 1. So the value is decreasing at a rate of 0.6%, right? Because 1 plus R is equal to 0.94. So R is equal to minus 0.06. So it's decreasing at a rate of 6% per year. And you would say the purchase price of the car was the starting value here you see in front. Okay. So that is the ones I plan to talk about on all three subjects. Does anybody have any questions or problems that have puzzled you or something you want to ask? Any questions about that we covered? Anybody scratching their head?
I have a quick question, but it's not exactly about the functions.
Okay.
Taking the factors of the quadratic equations,
Okay.
I always get the signs backwards.
Oh, okay. Okay. You mean, so you're talking about factoring?
I'm talking about factoring and.
Okay. Well, actually, I've got a pre-calculus class right now.
Okay.
And in that, of course, they have to remember the factoring that they had done. And they get into not only quadratics, but third order and fourth order.
Mm-hmm.
And we learn how to factor those too. And they're still sometimes getting them backwards. So you're not the only one. Okay. That's, now I'm going to try to make up a problem. X squared. I'm going to, a very simple one. Okay.
Okay.
Now, you want to come up with factors. Do you remember the idea of foiling?
Of what?
Foiling.
Can't say that I do.
Okay. First of all, let's foil something. X plus 2 times x minus 3. So there's quadratic is factored. If you had to multiply this out, you foil it.
Okay, I got you.
The first, the outside, the inside, and the last. The first is x times x, which is x squared. The outside is minus 3x. The inside is 2x. And the last is 2 times minus 3, which is minus 6.
Okay.
It's x squared minus x minus 6. Okay? That's foiling. Well, when you try to factor something, you come up with and fill in these things. Obviously, you're going to have an x and an x. And then you need to have the last two multiply to get 16. And you could try 2 and 8, but that won't work. Okay. But 4 and 4 would give you the 16. And to give you the minus 8x, you need a minus and a minus.
Okay.
Okay. Now that's 0. Now to solve this, if you have the product of two numbers equal to 0, then one of them has to be 0. In fact, both of them could be 0. So we set each one to be 0. X minus 4 equals 0. And of course, the other one's the same. and solving x minus 4 equals 0, you know how to solve that, right?
X minus 4 equals 0?
Right. What is x?
Before.
Right, right. I'm sure you did that, but what you did was add 2 to each side. You get x equal 4.
Okay.
Same for this one, x equal 4. Now, some people see these factors and say these zeros are minus 4 and minus 4. Okay? But you have to set the factor equal to 0 and solve.
Okay.
Some people will jump to conclusion. Okay? So now, let's do this one. X squared minus x minus 6 equals 0. That's going to be x minus 3 times x plus 2 equals 0. Now, in your head, do the following. Obviously, the last 2 is minus 6. The x times x is x squared. The outside is 2x. The inside is minus 3x. So that gives you minus x. Now you set these equal to 0, and you get x minus 3 equals 0. X plus 2 equals 0. So x equals 3. X equal minus 2.
-2. Okay.
Okay?
All right.
Some people might just look at that minus 3 and say it's minus 3 and not go to the trouble of actually solving it.
Okay.
So if I could show you the first test one of some of my students, maybe 20% of them might have gotten this backwards.
All right. Well, thank you.
Does anybody else have a question? Destiny, do you have a question?
No, sir. I did have a question about the a greater than 0, but because I was like, when I watched the video, it was confusing about how I know if the a is greater than 0, 0 greater, or 0 is greater than a, but it depends on if the graph is going up or down, correct?
Exactly. Ax squared plus bx plus c. If a is negative, then it opens down. Okay.
Okay.
Okay. If a is more than 0, it looks like that. Now, do you have a graphing calculator?
Yes, sir.
Actually, a way to check yourself is to pull out your graphing calculator and put it in your, let's just, let me pull up graphing calculator. Put in, let's just do something simple. You can say y equal x squared. And I'm going to zoom to the standard window. Opens up. Now I'm going to put in minus 2 x squared minus x plus 3, and I'm going to graph it. What do you think that's going to do, Destiny?
Make a be less than 0.
Okay, okay. So it's going to point downward or open downward.
Yes, sir.
And sure enough, there it goes.
Okay.
In fact, you can always check your work about where the vertex is. Okay. In fact, while we got my calculator out, I need to go way back here. We asked to find the vertex of this. X squared minus 14x plus 24. Let's put that in the calculator. Of course, this is not required. So x squared minus 14x plus 24. And we know the vertex is going to be 7 and minus 25. So let's zoom to the standard window and we won't even see much of it. You don't see it, do you? You just see a part of it because it's going to be at 7 and minus 25. So we're not looking at y as low as we ought to look. So we go and change the y min to at least cover as low as we think it'll go. I'm just going to put in minus 50. Now we should cover that pretty easily. Okay, so now you see the vertex. And the vertex is right here. And so if you had one of these on a test, now the easiest way to do the vertex is what we just did, minus b over 2a, right? We know it's going to be 7 and minus 25. But you could put a trace on. The trace is at 0 and 24. I'm moving that cursor down close to the vertex. But I want to find out exactly the vertex. So I'm going to hit second trace, which is second calc. And it'll ask you, what do you want to calculate? I want to calculate the minimum, which is 3. It'll ask me what the left bound is. And I've got it towards the left. So I'm going to hit enter. Then it'll ask me the right bound. I'm going to move that over to the right and hit enter. And it asks you for a guess. Well, you don't have to guess, just hit enter. And it should tell you what the vertex is. Notice it got it a little bit off. It's really 7 and minus 25. Okay, but there's the vertex. I won't charge you any extra for that. Anybody got any other questions?
No, sir. Thank you.
Okay, I'm going to stop the share and I'm going to end the meeting, and I'll put the video out right after this. You all have a good evening.
Thank you.